Welcome to the second lesson, of which we are going to look at differentiating using the general formula, the general rule. The first one we are looking at differentiating using the first principle, and now we are going to look at differentiating using the general rule. Okay, so as I talked earlier on to say differentiation using the first principle, to some extent, you might be failed to use it because of the nature of the equations that may follow. So differentiating using the general rule, what is the first step that you have to do? We already know that when you have the f of x, this f of x, sometimes it has got a number which is a coefficient, then you have a variable and the power. So this one means the coefficient, then this is a variable, and this is a power. Okay, so when you're differentiating this type of the function using the general rule, what is the general rule states? Okay, so we are finding f prime, of which in other terms we can say dy dx, is equal to, so the first thing that you have to do is to multiply this power times the coefficient that is in front of x, which means you are going to have n multiplied by the coefficient of a, then you have x to the power n. So now what happens to the power there? You subtract 1. Okay, I'll repeat again. When you are finding the f prime, or in other terms dy over dx, when you're differentiating using the general formula or the general rule, that means the coefficient here and the power, they are going to multiply each other. So this power is going to come this side where the coefficient is. So you are going to have an, na. So you multiply the power n times the coefficient a, then x, which is the variable, to the power n, you subtract it with a 1. This is the general rule. Okay, so let's go straight into our first example. Which says differentiate y is equal to 5x to the power 7. Okay, so remember now, if we were dealing with the differentiating using the first principle, we could have started 5 open brackets x plus h to the power 7, then you expand this one. You could have had something like this: limit when h is approaching 0 is equal to 5, you open brackets, x plus h to the power 7. Then you start expanding this one to the power 7, of which you're going to find that you're going to waste a lot of time just finding this. So now that's why now the general rule is coming in to help us differentiate this. So I'm going to say y prime is equal to, we said the power should multiply with what? The coefficient. So we're going to have 7 multiplied by 5, x to the power 7. The power should do subtract 1. Okay, so what is now 7 times 5? So y prime is equal to 35 x to the power 6. So this is our answer. It looks simple. Rather than using the first principle. The first principle will become law when we are dealing with this one. But when we deal with the general rule, this one becomes very, very simple and straightforward. Let's look at the second one. Y is equal to 4 over x squared. Okay, so when you look at the nature of this equation here, this equation which is given, 4 over x to the power 3, you can bear with me that this one can be changed to 4x to the power negative 2, the laws of indices. So this is same as we 4 over 1 multiplied by 1 over x squared. You know that 1 over x squared, we are going to have 4. When you change this one, you take it into negative index, you are going to have x to the power the negative 2. So we've changed this one from a fraction into this form. So from here now we can nicely differentiate. Finding the y prime is going to be negative 2 multiplied by 4x to the power negative 2 minus 1. Always you remember to subtract 1. So our y prime is equal to negative 8x to the power negative 3. So how can you write this one? We can take it back into a fraction form, which are going to have negative 8 over x to the power 3. That would be our final. In case you can't see down here, 8 over x to the power 3. That is our final answer. Okay. So now what else are we going to do? Let's look at another question. Look at the other question, which will be a little bit long than we expect. Okay, so we have this question here. Differentiate y is equal to 2 over 5 x to the power 3 minus 4 over x to the power 3 plus 4 square root of x to the power 5 plus 7. Okay, so what are we going to do? We have to check first if there's anything that we can change. So we've seen this one, we can change it into a negative index. We can also change this one, we remove the square root there. So we first have y is equal to 2 over 5 x to the power 3, then minus 4x to the power negative 3 plus 4x to the power 1 over 2 means it means the square root. We multiply it with 5 plus 7. So again, we are going to have y is equal to 2 over 5 x to the power 3 minus 4x to the power negative 3 plus 4x to the power 5 over 2 plus 7. Okay, so once we've taken this equation into this form, we are now going to start finding our dy over dx. So we are saying the power should multiply with this, then you subtract 1 from the power. So we have 2 over 5 times 3 x to the power 3 minus 1 minus. So this minus also will come here, so we're going to have plus 3 times 4 x to the power negative 3 minus 3. Okay, plus we are going to have 5 over 2 times 4 x to the power 5 over 2 minus 1 plus. So here when you have a constant, when you differentiate a constant, you are going to have a 0. Okay, so how do you have a 0? So remember, same as you have 7 x to the power 0. That's why x to the power 0 it is 1. 7 times 1 it is 1. So when you multiply this one times 7, when you multiply this times 7, you have 0 times 7 to the power x to the power negative 1. When you multiply these, they will give you what? Just a 0. That's why when you have just a constant number, you know that when you differentiate it, you are going to have a 0. Okay, so we continue. Dy over dx is equal to, when you multiply this, we are going to have what? 6 over 5 x to the power what? 2 plus. When you multiply this, we are going to have 12 x to the power negative 4 plus. When you multiply this, you are going to have what? 10. 2 there, 2 there, 2, then 5 times 2, that is 10. X to the power when you subtract there, what are you going to have? So you have 5 over 2 minus 1 over 1. Common denominator, it is 2. 2 into 2, 1. 1 times 5, you have 5. Minus 1 into 2, it is 2. 2 times 1, it is 3. 5 minus 3, you're going to have 2 over, you're going to have 3 over 2. It is 5 minus 2. So this power, you're going to have 3 over 2 plus 0. So we forget about that 0 there. Okay, so our dy over dx is going to be 6 over 5 x to the power 2 plus, remember you have this negative index, we take it back into positive index, so you have 12 divided by x to the power 4 plus 10. So this one you can also take it back into a root, x to the power 3. So this is our final answer. So you just follow term by term, term by term, term by term, term by term, then you differentiate. So the first thing we did here was to change this fraction into a negative index. This was in a positive index. Also this one, we remove the square root. We take it back into proper numbers that can be simple for you to work out. And afterwards there, you differentiate, and then you take it back into the positive index and into its square root. Okay, so I'm going to give you some tasks. So you're going to try out these task questions. Differentiate f of t is equal to 5t plus 1 over square root of t to the power 3. Then the second one, y is equal to open brackets x plus 2 gross squared over 2 over x, I mean. Then you have y is equal to 6 plus 1 over x to the power 3. Try out this and just inbox me the answers that you're going to find. Thank you so much for watching. Shalom, shalom.